iniziare. Stai trasmettendo dal vivo. Hello everyone!
Hello everyone, we are live on YouTube with our fourth edition of Stay Home, the online event of Speck&Tech. Here you can see on your screen there's quite some people in the chat already. We're going to stay here all night long and mingle and talk with our speaker, Marco Gomiero, but we'll tell you a bit more in a few minutes. As always, we will start with a brief introduction of what Speck&Tech is, what we've done in the past, so just that you know who we are and to give you a bit of context. As I said, this is the fourth edition, but there's a long story behind Speck&Tech. We started back in 2016 with physical events hosted in Trento in Impact Hub, a co-working space. And the thing scaled. We got up to 150 something participants. And we were actually serving Speck at the events, as you can see. And people were getting some Speck, some cold cuts, some beers, some chips, and talk with others and meet people all night long. And in 2018 and in 2019 as well, we organized some retreats in the mountains with the community in Trento. And actually, it's funny because it was actually this weekend. So this year, there's going to be no retreat, and many of you will be very discomforted. But this is life, and we hope we will get back faster and stronger in 2020. In 2019, we had some very big speakers. We hosted a number of events and a great collaboration with Muse, the Museum of Science in Trento. And then we moved to a new venue, which was our home in 2020, Le Gallerie. But then things happened, and after more than 40 events and more than 5,000 participants, we went fully online for now, of course, and we will see what things will happen in the future. But for now, we're staying home and safe. And that's the new format. So my word goes to Giulio.
All right, thank you, Francesco. So hello everyone. So we found a new home on the internet, and tonight we are super happy to host Marco Gomiero, who is a developer and who will talk about Declarative UI. If you have no idea what it is, this is your night to know it. Marco is currently a developer for Uniware, which someone of you may know because they do an app for the university where you can see a lot of stuff going on about university. If you're a student and don't have the app, you should definitely download it and send your reviews directly to Marco, which will be super happy to receive bug reports and any idea that you have in mind. It will promptly implement it. Jokes aside, he is actually on the team of the app, and it's super cool. All right, so if you want to stay up to date with all our information, you should definitely check it out our website. Since we are fully moved to the internet, here you can find all the updated things about our events and our previous events, comprehensive of the presentations and the videos, if possible. Some of the previous speakers were super secretive. Moreover, now we are on YouTube, so don't forget to subscribe and the thing with the notification that you do on YouTube, I have no idea. Yeah, click on the button, that kind of things that YouTubers say. Also, as of tonight, we have a new thingy that I tried to set up on our streaming, and we can see real time if you just subscribe to the channel. So last one is Federico Natali. Thank you, Federico.
Wink, wink.
Yeah, I have no idea who Federico is, to be honest. All right, so, and moreover, I highly suggest to subscribe to our Telegram channel if you want to stay up to date. That's the best way to stay up to date with all the notification and stuff. We don't spam too much, promise, and you stay up to date with new events.
Of course, you can support us. There are a number of ways for our most loyal speakers, of course. You know that you could pre-order our T-shirt. We are super happy. This year we got over 80 pre-orders, which is an incredible number considering the size of the community. Which means that almost one person out of a couple of them got the T-shirt pre-order, which is really a great result. They are on the way. They should get ready for in a couple of weeks. We will tell you more later. But if you really want to support somehow, you can go to our S.T.A.Y app. You can go to S.T.A.Y, just look for companies and buildings around Trento, and there is actually Speck&Tech out there, and you can send us some money and some love. Otherwise, you can always go to Spaziati or Belka. Belka is Giulio company, and they're actually looking for.
Yeah, we're looking for a web developer. So if you know anyone talented or you are talented and fluent with a beautiful language, which is JavaScript, probably the best language ever invented by humankind. Joke aside, we are actually looking for someone. There is all the information regarding the open position on our website, which is belkadigital.com.
Exactly. At the same time, Spaziati, which is our company, we are actually looking for backend developer, front-end developers, and also project managers, kind of mixed figures. So if you just go to spazidati.eu, you can find more information about the roles that we're looking for. That's more or less it. Thanks for listening. And now we head on to our speaker of the night, Marco Gomiero. As always, you can ask all the questions that you want on Slido. You just go to slido.do/stayhome, or you just go to Slido and insert the code stayhome. And the questions that will be asked there will be prioritized based on the upvotes. So you can also upvote others people's questions. And at the end of the talk, we will ask some questions to Marco. So I think that's all from us. And I wish you a good evening. And then we leave the word to Marco Gomiero. Marco, you can take the screen sharing.
Yeah, all right. And
All
a
right.
virtual applause to Marco. If you want to spam some emojis. Welcome.
Thank you. I'm gonna share my screen. All right. Okay. Okay. Now you should see my screen, and if you are not seeing, let me know. First of all, sorry, Giulio, but I have to say that Kotlin is the best language ever invented by you. And beside jokes, let's start. And this night, I will talk about imperative and declarative style for building user interfaces. And with this talk, I don't want to go deeper into the single implementation and the specific implementation that different frameworks has, but I want to give you an high-level overview of how declarative works, because if you understand on an higher level, you will be able to pick any framework of your choice. All right, so this was a presentation slide of me, but Giulio already said lots of things about me. So the only thing that I want to say is that my background is mainly Android, but during the years I also learned iOS development, and I've done some cross-platform stuff with React Native and Flutter, and mostly with Flutter, fortunately for me. And these are my social handles if you want to follow me on the web. All right, so let's start, and let's assume that we want to build a client for reading news from Hacker News. So first of all, we have to download the news. So we need to show to our user a loading. And so a loading state, and after that, things can go wrong. So we have also to build an error state where we show to the user some information and maybe a retry button. And finally, we have to show a success state, of course, where there are all the news ready to be read. So how to build that application right now. And by right now, I mean with an imperative style. We have to do a lot of things, and let's see what we have to do. First of all, we have to define the view, and on Android we have to do it in an XML file. And instead, on iOS, we have to do it in a storyboard. And in these two places, we have to define all the state and all the pieces of UI that we want to provide in the different state. So in our case, we have to put in a single place the loading state, the loader, the button, and the message for the error state, and the list, and so on. And as you can imagine, this is a mess because you have to put everything in one place, and the perfect description of that mess is the screenshot. And I think that you aren't understanding what this screen is, because it is just a stack of things. Next, after dealing with this magical storyboard thing, we have to connect the dots and connect the UI that we have just defined in the XML and the storyboard to the actual code. So we need to ask to the view owner the specific instance. So for example, on Android, we have to call the find view by ID method by passing an ID. And this method returns an instance of what we want, in this case, a progress bar. And on iOS, instead, we have to define an EB outlet, and we have to do it with a super magical, powerful, amazing method that is drag and dropping from the UI to the code. And yes, this is a thing that I totally hate. And after that, in our case, we have to write some code to handle a list. And on Android, we have to implement a recycle view adapter, and where we define how the different cell of the list will look like. And on iOS, instead, we have to do a similar thing that is implementing the table view delegate and the table view data source, and or the collection view delegate and collection view data source if we are using the collection view. And finally, we have to add some logic to make our view react to the different state. So for example, on Android, we have to check if the state is loading. And if the state is loading, we have to show the progress bar and hide everything else. If the state is error, we have to show the error message and the error button and hide everything else. And the same for the success list, for the success state, sorry. And this is a lot of things to do. We have to write a lot of code and a lot of boilerplate and boring code. And since the code is boring to write, also there will be potential bugs because this is a law. And another reason for bugs is the fact that we don't have a single source of truth. And we have some truth, we have the truth spanned into different files, into different places. And for example, we have some truth in the XML file, we have some truth in our file, so for example, in the activity or in the view model. And we have also some truth in the UI components that we are using. So if there is a bug, we have to think where the bug is, and if we have to add something, we have to add in different places, and it's a mess, and this causes a bit of headache. And another problem is the fact that, for example, when we retrieve the view instances and we store the field that contains the view instances, the view instance, and let's suppose that that specific UI component is not in the tree anymore, and we want to use it. And there will be a beautiful null pointer exception because we have we have the reference to the instance, but the instance is not in the tree anymore. So with the imperative style, we have lots of boilerplate, we have potential bugs, and it's hard to maintain, basically. And this was the imperative style, and this is not a very good presentation about it. And the reason is because the imperative style make us describe and say what we want to see and how we want to see. So we have to describe and write the code for our screen, but we have also to write the code to move from one screen to another. And of course, it will be wonderful if we can say only what we want. And of course, we can do it with the declarative style. And the declarative style is, as I said, is about defining only what we want, and the system will handle for us the conversion between one state to the other. So, for example, if we have this screen that is in the state A, and so, for example, we can imagine that this is the loading screen, and if we want, we have another screen that is another state. So, for example, the state, the success state. All we have to do is define these two screens. And then there is a magician, let's call it a magician, that does the magic things and transform the state A from the state B. And okay, seems very, very beautiful, but how things works in details, how the magic can happen. Well, let's see it with some maths. And we can model our UI with an equation, and we can say that the UI is a function of the state. And maybe it's not so clear right now on the meaning of that equation, but during the talk we will explain better how it means. For now, take it as granted. And the state basically describes the UI in this specific moment. So what to show now. And the state is independent of the previous and the next state. So basically, it doesn't care less on how the previous and the next one will look like, because if there are some changes, and so if the state changes, the UI will be another, because the function of the state, because a different function of the state will create another UI. So if there are a change, the UI is redrawn. Of course, with some optimization, because we don't need to redraw things that is not changed. So all the changes and all the re-rendering are managed by the system. But how the system can do such a thing without us telling what to do? Well, the system creates an abstract representation of the UI before rendering it. So, for example, a specific screen will generate a tree like this. Every node of this tree is a specific piece of UI. So, for example, a button, a card, an icon, and so on and so forth. And when there is a change, the system creates another representation. And with some magic, that it's the second name of algorithm, computes the differences between the two representations. And so in this way, the system knows the differences, and it renders it, of course, if there are some differences. And this is how a declarative magician works. And of course, this is a high level overview, but you can, the main concept are this. But how it works in details on the different framework, well, of course, it depends on the framework. And now I'll show you some examples of that implementations. But of course, you don't need to know all the differences and how a specific framework works. You can pick up a framework and use it without knowing the internals. But if you are interested, it's really interesting to know the internals, at least for me. All right, so let's start from React or React Native. And React was one of the precursor of the declarative stuff. And React basically creates a virtual DOM as the representation of the UI. So for example, from this piece of UI, it creates a representation like this. So basically it's a JSON that represents a tree with all the information of the button in this case. And then the representation, the differences between the different representation are computed with a 3D thing algorithm that is called reconciliation, and that does some magic and some tricks to be an algorithm with a good performance. But I will not going deep into it, even if it's so fascinating. But I leave for you some references if you are interested. All right, Flutter instead, that is another cross-platform framework built by Google, creates a simple tree as a representation of the UI. So for example, from this menu, it creates a tree like that. And in Flutter, everything is a widget. Every piece of UI is a widget. Also, the modifier of the UI are widget. So, for example, the padding is a widget, and even the application itself is a big widget. And in this case, every node of the tree is a widget. And Flutter uses a 3D thing. Not uses a 3D thing algorithm to compare the differences, but for each node, it looks to the children. It looks to the children and it understands what are the differences in this way. Again, I'm not going into the details, but I leave it for you some reference if you want to dig around. And final example is Jetpack Compose, that for the one for people that don't know it, Jetpack Compose is the declarative toolkit for building user interfaces on Android, and it is still under development. It currently is in alpha stage, and it's not ready for production, but it's ready for pet project and for trying in not production project. And Jetpack Compose uses the slot table as the representation of the UI, and a slot table is a structure similar to the gap buffer, that is a structure that is used on the text editor. And basically, in this sort of array, there is a buffer, and so a gap, that can be moved up and down inside the structure to allow cheap insertion and deletion. And basically, the system assign to each piece of the UI a key, and saves that piece of UI in the slot table. And so in this way, it knows if something is changed or not. Again, I've described it in just 2 words and brutally. But if you are interested, there is a talk by Leland from Google, and a very interesting talk, by the way. And there are also 2 or 3 blog posts that describes the internals of Jetpack Compose. And if you are interested, I leave you a link at the end of the presentation. So we have seen how the internals works. Now let's try to understand how actually the pieces of UI are built. And let's see some examples. And on React, the UI is defined using components. That basically is a class with a render method, and we have to return in the render method our UI. So in this case, a view with inside some texts. On Flutter, instead, there are the widgets, and as I said before, the widgets are the main building block of Flutter. And a widget is basically a class, and we have to return our UI structure inside the build method. That is the equivalent of the render method in React Native. On Jetpack Compose, instead, we have the composable function that are basically Kotlin function, special Kotlin function that are annotated with the composable annotation. And so in this way, the compiler knows that this type of function must be translated into a UI hierarchy. And so inside the function, we return our piece of UI. On Swift UI, instead, that is the declarative pattern and toolkit for building UI on iOS and macOS. We define the UI with the struct, and again we have to put the definition of the UI inside the body variable. So we have a different way to define the user interfaces. That depends on the framework that we are using, but we can abstract that representation with a function. And of course, a function of the state, as we have seen before. But this function must be special. And by special, I mean that this function must be pure function. And let's see what pure function is with an example. So in this function, we have 2 simple input that are 2 numbers, and the return value is the sum of these 2 values. So we are doing a transformation of the input. We are not changing the input, and so we take some stuff, we transform it, and we return it without any kind of side effect or strange things. So this can be considered a pure function. This function instead takes as an input a bank account object and an amount value. And the function modifies the balance inside the bank account by subtracting the amount. So in this case, it is modifying the input directly, And this is not a very good thing, because if another piece of our software is using the bank account, there will be some side effects, and something is changing in another part of the software because someone else changed it. So it's not an ideal situation. And so this is not a pool function. And so we can summarize the definition of pool function with just these two definitions. So a pool function is a function that returns the same value given the same input, and is a function that has not any kind of side effects. So in our case, we have like we have seen in the component, in the widget, in the composable function, in the struct, we have some value. So we have some value as an input. So, for example, one input can be the news from Market News, and as an output we have a piece of UI. So basically, we have a function that takes some inputs and returns a piece of UI, and that kind of and this basically explains the beautiful equation that we have seen before. So the fact that the UI is a function of the state. And as we said before, the state is the representation of the UI in this specific moment, right now. And if the state is modified, there will be another UI. So if we have to render a specific state, and before returning our piece of UI defined by that state, we modified that state, we need to return another UI. And if we are again modifying that state, we have to return another UI, and so on until we land the memory of the device, and our application will crash. And I've done it sometimes, and just to try, of course. And so we can't modify the state inside the function that defines the UI. So how we can modify that state? Well, let's try to understand with an example. And let's assume that we have to use this switch inside our application. And this switch is defined by this piece of code. And this piece of code is a mixture between different declarative framework. So don't try this at home, because I think that it doesn't compile or it doesn't do anything. But of course, for this specific situation and for the example is okay. So let's assume that we have this material switch inside our application in a specific position, and let's assume that the tree of the screen on which there is the switch component is this one. So at the root there is the state holder, so an entity that manages the state. And at the bottom, there is, and in one of the leaf, there is the switch component. So we have to update that switch component to be rendered with the selection on or off. And this information is contained in the state. And that maybe search that information on a backend, on the database, or whatever, and the information navigates the entire tree to the switch component. And so in this way we can put our switch on. Next, if there is a changes, so if the user clicks on the switch, we need to update the visualization of the switch, and we need also to update the state. So the information flows up from the leaf to the root, to the state holder, and the state holder saves that information to the backend, to the database, or in a beautiful text file. And then, after saving that, the information of the new state goes down again to the tree to update the switch. So all we need to remember is the fact that the properties goes down to the tree, and instead the events goes up to the tree. So we have to take in mind this pattern because we have to do in this way if we don't want to crash and empty all the state, all the stack of our application. All right. Another interesting, the last interesting and important concept to take in mind when you are dealing with the declarative world is the concept of composition. And on a declarative pattern, in general, composition is preferred over inheritance. And this is a very, very good thing because again, it saves us from quite a lot of headaches. And let's see why. Let's see with an example. So, for example, we have a container and a news card that are two different views. And let's assume that we want to create a news card container. So basically a card that contains a container. And to do it with inheritance, it's difficult because, for example, we can't inherit from two different objects. And maybe in this case, we have to do an intermediate object. And if things change in the parent, we have side effects in the children, so we have to update also the children, and this is boilerplate code to write and hard to maintain. And another thing to take in mind is that we are going to inherit things from the card, maybe we don't need. And instead, with the composition, all we have to do is stack together the card and the container. So in this case, the system will render a card with inside a container. And that's it, easy peasy. We don't need to override the functionality from the card, to update it if it changes, and so on. It's simple and more easier to maintain. All right, so we have seen lots of interesting patterns, lots of interesting things on how declarative works, and now we are ready to migrate our application from an imperative style to a declarative one. So let's give a look and to the snippet that I've already showed to you before. And in this case, to make our UI react to the state, we need to do lots of things. So for example, if we want to show the loading state, we need to show the progress bar and hide everything else. For the error state, again, we have to show the button, show the message, and hide everything else. And maybe you have already spotted, but there is a bug in this code. And in the error state, I've forgotten to hide the progress bar. So when we are trying to a failing network error, there will be a beautiful progress bar above the message and the button. And this is a classic error on the when we are dealing with the imperative style. But fortunately, there are all the UI and integration tests that will let know us if something is wrong like that. No, I'm just kidding. All right. Besides jokes, next we have to, of course, also show the list in the success state, and this is lots. And we have to write lots of code that even not fit in an entire slide. And instead, with the declarative style, all we need to do is this. Very simple, very easy, very clean. So if there is a loading state, we can simply return a loading view. For a success state, we can return an use list view. And for an error state, we can return an error view state. Easy peasy. And of course, this was only a piece of the entire application. But if you are interested to dig around a little bit more and see all the differences, I've published on my GitHub a repo that contains the same application developed with a declarative style and an imperative style, both on Android and iOS. And as a bonus, there is also an example with the React Native and with Flutter. And I've tried to develop all these clients very similar between them. So you will see that the differences are very, very minimal. And so I was not lying that if you understand the main concept, you will be able to jump between different frameworks of declarative framework. For example, I've started with Flutter, then I moved to React Native, and I was shooting myself because I don't like JavaScript, but I was able to use the declarative pattern. And next, I moved to Jetpack Compose and Swift UI, and I was, let's say, at home because I was already be able to move and understand how to define stuff. All right, so let's jump quickly to conclusions. And in just 2 words, the declarative pattern is about describing what we want, not how we want. So in this way, we can write less code, and if we write less code, of course, there are fewer bugs on our code, and of course, this is a law. And I understand that this is a totally new paradigm, so it requires time to understand and to start and to getting used to it. So don't worry if you are not understanding right now how it works and you are not able to build a astonishing UI just in 2 minutes. But take your time, try and dig, and you will understand all the benefits in the long term. And of course, I want to remark that you don't need to know the internals if you want to use a declarative framework. You can start even if you don't know how it works. It's totally fine. But of course, if you like to look to the internals, I can guarantee you that it's very, very beautiful and interesting to understand how that stuff works. All right, so as promised, these are some references that I've used to build this talk, and also some reference that can be useful to understand more. And that's it. Thank you very much. If you have any question, I'm here to answer, and or you can tweet and reach me out on Twitter, and on the web.
Right.
Thanks, Marco.
Thank you very much, Marco. I finally have some more ways to understand what developers are telling me, which is always nice. So
We already have some questions,
yeah, we
but
have a couple of
I'm
them.
sure a few will more. Yeah, a few will more will come. Shall we start with the first one, Julio? Do you want to
Right.
go?
Yeah. Go.
So the first question is, what do you think about Compose? Will it be the future in Android app development?
Yes, definitely, because it's the future, and all the declarative way to do things is the future, and the team is working hard on that, and also it integrates very well with the the system and with Kotlin. And also a good thing is the fact that it is separated from the operative system release. So it's not right now for new update on the view of the view system, you have to wait a new release of Android. And with the Compose instead, it's simple a library, so it's better. And another thing interesting is that JetBrains that is as a team that is working on Compose. So probably it will be a possibility to use Compose also for developing Java computer application, as desktop application. And so I have a big dream that is using Kotlin multi-platform with Compose, so I don't have to even write a single line of Swift. So maybe this one.
I've
Let's
already
see.
heard this story about this language called Java. I was trying to do the same thing, so let's see.
Well, it's different because
Yeah. They were saying the same. No, it's just a joke.
No. You are touching a hot nerve on me.
Yeah, I know.
No, it's different because on Kotlin multi-platform, you are not building on a virtual machine like in Java. You are building the actual native code.
No, but I got it. I was just joking with you. Sorry. I was just joking.
I'm joking with you also.
Yeah. Write once, run everywhere, kinda.
9 billion devices.
Yeah. What could go wrong? One thing before the second question. If any of the people who are in the Google Meet right now want to ask a question, just unmute your microphone. You're super welcome to ask it by yourself. Otherwise, if you're shy, no worries. You can write it on Slido. We are not shy, but still, like, you can chat with Marco. He's friendly, and also accept Java jokes. So he's super friendly. So they're asking you, if you had to choose a language, which one would you pick and why? I mean, you pretty much answered this one, but
yes, I will pick Kotlin because I like it very much, and because I can write multi-platform stuff with it. I can write for desktop. I can write for mobile, for Android, for iOS. I can write also for embedded things. I can also write for web. It's not. I think that is not a place to the right place to say shit about JavaScript. But
no, it's not. You stepped on the wrong path. It's now you can speak your mind. Like, if you have some opinions about that, I would more than welcome to listen to that. I mean, I'm not married to JavaScript, and
okay.
so if you have strong opinions, go with it. We are super eager to see your point of view. That's why we invited you. So
yes, I'm more object-oriented guy. I want that the compiler say me things, not and not a real compiler, not a TypeScript compiler that sometimes does not do things like a real compiler. That's one of the reasons.
that was tough. If fan of TypeScript are listening to us, we would like to remind you it's Marco's opinion. No, I'm joking. all right. All right.
Opinions are my own.
Yeah.
You were also touching the topic of web development, and actually our last question that we have here on the Slido is, do these concepts apply only to app development or also in web or desktop applications? I don't really know which concepts, but I guess most of the things you discussed about.
Yeah, I believe the imperative versus...
Yeah.
Yeah.
The declarative style is in the web since many years, I guess. It's the mobile world that is catching up with the declarative pattern. And the precursor, as I said, it was React, and then Flutter, and then all the other native competitors. So yes, the core of the question is that the mobile world, these concepts are applicable also to the mobile world, but I've centered this presentation on the mobile world because I'm a mobile developer. But of course, you can translate all this stuff to the other situation. I don't know if for the maybe for the desktop world is tough right now, but because the classic way for doing desktop, and I mean with a Java application or a Qt, I think that are definitely not declarative, but if you do a desktop application with Flutter or with Electron, that concept are applicable too.
Yeah, right. Which is like most of the application which are developed right now on desktop nowadays, since developers.
Unfortunately, are read.
I kind of agree on that. Like, I'm a strong JavaScript advocate, but yeah, I kind of would agree on that. Even though like some of those applications got lighter through time, you can think about Slack is a good example of that, but still, it has some heavy limitations. Still. Right, that was the last question, I believe. So if none of the people who are still live with us on Google Meet want to ask you something, we are wrapping up.
Exactly. Otherwise, worst case, we can go on and you can ask all your questions off the mic. And thanks, Mark, again for your talk. And
of course, if you have another question, you can reach me out on Twitter as well.
Yeah, he does reply. He's friendly. Right to Marco.
Of course.
Also, he's working remotely for his company right now, so he's kind of lonely sometimes. Writing about compilators, so he gets happier.
So hope to see you in person when the thing is over, probably in Trento, and when we will be back to host physical events.
Of course.
And of course, all of you here in the chat and everyone following us on YouTube. And I guess we will see each other in November with next event. And meanwhile, take care and have a good evening.
Yeah. Bye-bye.
Bye, guys. Thank you.
Thank you. Bye.
Ok, ho staccato.